Very good morning. We are in the that last lecture for multivariate normal distribution, and you have seen that it's a continuation. This is the fourth lecture, and today we primarily discuss how to examine data for multivariate normal distribution in the sense that whether data is multivariate normal. You will be happy to fit the normal density function, and with example we will see what are the tools and techniques available for checking or examining the data whether it is coming from multivariate normal population or not. Let us see the next.
Now, we will discuss another important aspect that is very important for all of us, that when we collect data, suppose we collected data n cross p and our data points are like this. We are saying that we have collected the data from multivariate normal population, MN population mean multivariate normal population, and we are defining that our x is multivariate normal with p variables mu and sigma, the population parameters. What is the guarantee that your data is multivariate normal? It is true that if your population is multivariate normal, the data you generate that will be multivariate normal also, but you don't know you don't know whether that population is really multivariate normal or not. So, what we do there, we examine the data to understand that whether data comes from multivariate population or not. So, in this case, in multivariate domain, we will use chi-square quantile plot, QQ plot, chi-square quantile plot. Q stand for quantile. What is quantile? Any idea? You know median. So, how do you get the median? Your data point, you first order the data from smallest to largest ascending, and then you find out the middle location, and you say if this is my variable x and what is the middle value of x, that is median. So, when you are making median, how many parts you are making for the data? 2 parts, okay, 50-50. So, this is one side, this is another side. You know quartile will make partition the data, total data into 4 parts. This is my quartile 1, quartile 2, quartile 3, quartile 4, and we know that Q 1 and Q 3 is the interquartile range that we have discussed in descriptive statistics. So, when you make quartile, you are making partitioning the data into 4 parts. Now, you do one thing, you partition into 100 parts. What will happen? Sorry, that is percentile. So, median, then you are saying quartile, then you are saying percentile. Suppose I do not want like this median quartile, I want to partition the total data set into n parts. Then what name you will give? You cannot give, you have to have some name, that is quantile. So, that means if you partition the data into 2 parts, the median, that is also quantile, general name. quartile is also quantile, percentile is also quantile, and if you partition even more or less number than the 100 parts, then that is also quantile. So, by quantile plot we want to see that how multivariate normality will be assessed. Okay. For example, suppose you have collected n data points, 1, 2, 3, n data points you have collected. Let the data is x1, x2 on xp variables, and I am sure all of you are in a position to fill up this. Now, we will calculate the d square value, Mahalanobis d square, Mahalanobis d square. I am writing this one as d I square, where I stands from 1 to n, correct. So, what is this? So, you have some reference point somewhere. That reference point definitely, if it is a p variable case, then it is the mu vector, mu 1, mu 2 like mu p. You are getting on p variable, you are getting, this is your first observation, this is your second observation. So, like this, if there is ith point, you will be getting x I 1, x I 2, x I p. So, this is your ith observation. Now, you want to find out where does that ith observation lie. Mean, if we consider a two dimensional case, this is my mu 1 and mu 2, then somewhere here this is my ith observation is falling. So, I want to get this distance. I think we have discussed the statistical distance part. What is the formula for statistical distance? X minus mu transpose sigma inverse x minus mu. Now, in Mahalanobis distance, the formula is x minus mu transpose S inverse x minus mu. Getting me? So, when I say d I square, I am saying x I minus mu, but I do not know the mu. So, I will write x I minus x bar S inverse x I minus x bar. So, if you write in this format x minus mu transpose and this sigma to the power minus n x minus mu, in the this is the exponent of the multivariate normal distribution, that also follows chi-square distribution, that is the general statistical distance. But when I say this is S inverse, this is we say that Mahalanobis has developed this. So, for every observation you can get this distance. Okay. Now, x I is what? X I is x I 1, x I 2, x I p, p cross 1. So, x I minus x bar transpose S inverse x I minus x bar, what will happen? What is this? This is 1 cross p, S inverse will be p cross p, and this one will be p cross 1. So, resultant will be 1 cross 1. So, you will be getting a value, I am writing here, suppose this is d 1 square. For the second one, you calculate d 2 square, same formula. Like this, you will be getting d I square, then d n square. Correct. So, what are the steps then? You have collected data. There are n multivariate observations. We want to compute the distance of each observations from the mean vector. Here we will be concentrating on the sample mean, that is x 1 bar, x 2 bar like x p bar, that mean. So, you require to calculate this mean vector, you also require to calculate the covariance matrix. Once you know this, you require to calculate S inverse. This also will be P cross P matrix. Once you all those things you have computed, then you go for di square. For I equal to 1, take this row, first row, put here, every observation will be subtracted by the corresponding mean. Okay. Then then you go for the second one, third one, like this. And using this equation, you are in number of distance values. Now, depending on the observation value, it will be different types. For example, what I mean to say, now from a set of multivariate observations, you calculated the distance and finally, you got data matrix like this, d1 square, d2 square, di square, then dn square, that is what data you got, and this one I am saying this is my d square matrix. So, what you require to do now, you have to find out the quantiles. Please remember, we say quantile plot. So, if you require to know the quantile, the one of the issue is you have to arrange these values, observed values in ascending order. So, if I say my ascending data for the distance values are like this, d within bracket 1 square, within bracket 2 square, like this, d within bracket I square, like within bracket n square. This is my ordered data. So, you will be having smallest to largest data set. Fine. Now, how many data points you have? N data points. You create n quantiles here. So, your 1, 2. So, you are now partitioning the entire data, this data, transform data, distance data, partitioning this distance data into n quantiles. What will be the distribution of this di square? What is di square? X I minus x bar transpose S inverse x I minus x bar chi square, correct. So, this follows chi square as p variables are there, p. Then as I know that d square is chi square p di square, and what you have created? You have created a data matrix now, different data, that is n cross 1 transform data d, and which is chi square distributed. So, that means all those this can be a chi square axis. I can get for quantile all points chi square value I will be getting. Now, di square is chi square distributed. So, from di square, if I compare with the chi square quantile values, I must get a relationship. Understood or not? This is nothing difficult. Suppose this is my chi square distribution. For example, let like this is your chi square. You know the lowest value and largest value from the data set, it is known. What is this chi square value? If I say I want to know this chi square p, what will be this value? You require to know then what is the probability right hand side, getting me. So, if I know that what is the probability of this, and if I subtract by 1, I will be knowing the what is the probability of this. So, with respect to this probability from chi-square table you will be getting this value. Similarly, for the second quantile value you will be also getting, third quantile value you will be getting, because you have n data set. This chi-square axis is partitioned into n parts. So, everywhere, so I am saying that you have chi-square 1, chi-square 2, this 1 and 2 not degrees of freedom, these are the observation, that is the quantiles. So, like this you will be getting chi-square n values. Now, as we said that d square is chi-square distributed. So, there will be relationship between d square and chi-square. If you plot d square in this side or di square and chi-square in this side, you will be getting a straight line like this. Okay. You may get here, may get, it will be a straight line, linear relationship. Now, see the problem given here. See, this is my data set bivariate case. We have considered 10 points, 1 to 10, and this is my first observation 93, 52.33. My second observation is 94, 53.46, like this. What we have done? We have calculated the distance for this observation, first observation, from the mean value x1 and x2, that mean value you have to find out, and from that mean value, and then using the distance formula di square equal to xi minus x bar transpose S inverse xi minus x bar, we computed this value 2.25. So, my first observation is 2.25 distance apart from the mean. My second observation is 1.40 this distance apart, unit distance apart from the mean, like this 102 and 63.71. This is the 10th observation, is 3.57 units apart from the mean. Okay. Understood? Now, this is the calculation part only you have to utilize this formula carefully. If you use this formula, you are in a position to get this. This is your first step. What is your second step? Second step is order, because you want to find the quantile values. So, you order, that is ascending order. Okay. Third one is you find out the chi-square quantile value. What is this? Chi-square p n minus I plus half. This is the chi-square quantile value. What is happening here? You see that you have 10 data points, I equal to 1 to 10 data points. So, these 10 data points ordered data points. So, that means your this is the chi-square axis, let it be, this is the chi-square variable axis. So, you have divided into 10 parts, 10 parts, 1 to 10 parts you have divided, and what will happen? Your chi-square will be something like this we have discussed. Now, what you want to get the chi-square value here. So, first you find out the probability value here, right hand side you use, because we will be using table. Then for that probability value you find out the chi-square value. That is why what you are doing here, you are writing chi-square p n minus I plus half. So, if I want to do little more manipulation here, what is n minus I plus half? N is 10, we have taken 10 data points. So, this is 10 minus 1 plus half, 9.5. So, we want to find out the probability. So, how many data points are there? 10 data points are there. So, if I divide by n again, so that by 10, So, that means this will be 0.95 and this one also you write this was by n, because this probability value you want to, this is the probability value, alpha value. So, your first chi-square, this value is chi-square 0.95. What is this value? You see here, .1. Then what will be the second one? 10 minus 2 plus half divided by 10. This will be 8.5 means 0.85. So, your second value here you find out for chi-square 0.85. 0.85. Chi-square 0.85 is 0.33. So, third one will be 0.75, 0.58, 0.65, chi-square 0.65, 0.86. So, like this. Then what we have done here? Then we have this side di square, y axis, x axis chi-square value, and when you plot these two you will be getting this type of straight line. Getting me? So, clear that your total data set is this, your total data set is this one. Every observation is transformed into one value, aggregate value, that is the Moulin-Béch d square, and you are now finding out the distribution for this, and we all know this is chi-square distributed. Using this property and the steps like this, plot. If you get a straight line, that is multivariate normal. If it differs substantially, then definitely that is not multivariate normal, but there will always be some amount of departure. So, what is that departure acceptable, that also you have to check. So, there are some other methods for checking also, like K-S test is there, Kolmogorov-Smirnov test, D max. So, you will be able to check all those things. Okay, this is what is our in totality the multivariate normal distribution we have discussed along with the properties. So, as it is very important one. So, first of all you must know that your multivariate normal density is 1 by 2 pi p by 2, then your covariance to the power half e to the power minus half x minus mu transpose sigma inverse x minus mu. Okay. And definitely your all j x j less than equal to infinite, j equal to 1 to p. So, there are two parts, one is constant and another one is exponent, and it is exponent which is very important. So, the exponent part x minus mu transpose epsilon inverse x minus mu, it follows chi square p. This distribution is chi square p, and this is also known as constant. This will give you the constant density. This will give you constant density. Now, in and this formula is chi square, this is chi square, but this quantity resembles an ellipse. Okay. This will be an ellipse when p equal to 2. For more than p equal to 2 variables, it will be ellipsoid. Okay. Then There is another concept called statistical distance. Keep in mind, this is very important concept, and constant density contours. The properties of multivariate normal distribution is important. Properties of MND, that if x is, what we said properties, if x is multivariate normal, then xj will be univariate normal, that we have seen, j equal to 1 to p. Now, if x is multivariate normal, subset will also be multivariate normal. So, that means, if I create a subset x cube 1, that will be q, mu q and sigma q. Then linear transpose of x, this will be your univariate normal with A transpose mu, A transpose sigma A. If you find out q linear transpose, then that will be your multivariate normal, that is A transpose mu. Only the matrix multiplicability, compatibility part from multiplication point of view you have to check. Okay. And then finally, when you collect data, the data must be examined and you have to check that whether data is coming from multivariate normal or not, and that is possible through chi-square quantile plot. There are other plots also, but we will be looking into this. Okay. So, I have given you one data set, that 5 variable data set. If you can find out whether the data coming from multivariate normal or not using the statistical distance concept, or you take your own data set, just test, use Excel or MATLAB. Okay, thank you.